We want to give a view on the connected car and new emerging technologies from a tier one supplier point of view. Just a few words about Motherson Group. So we are a globally, a tier one supplier. We supply to almost all the OEMs of the world, and we are located in about over 41 countries in 250 facilities, with about 24 R&D centers. And these are our different verticals: electronics and technology, wiring harness, vision systems. And I want to talk about how Motherson Group is kind of transforming and getting ready for the new age of connectivity in the vehicles, right? And that's so the idea is basically increasing the content per car every year. So we already are supplying bumpers, mirrors, smart mirrors, wiring harness. And talking about telematics, that's where we come in. We are the IoT and telematics division of the group. So we basically supply to OEMs and different B2Bs. We have lots of fleet management solutions and IoT integrations as our services. So talking about any IoT platform, right? So these are the three basic components that any IoT or vehicle telematics platform has. So there are different sorts of devices, starting from a basic telematics unit, going up to a very high-end infotainment system. Secondly comes the cloud part, and once you have the data on the cloud, we build lots of different applications. So while an OEM may want a 360-degree view of its latest vehicle rollouts, the dealership wants to have another view, and of course the end consumers want to have access to their cars, maybe on their mobile phone. So we kind of have built an very modular and open architecture. So maybe you can take a cue from probably how you could structure your cloud and telematics strategy. So we, as I said, that different sets of hardware we have built depending on the different requirements. So some of them are very basic OBD units. Some of them are with voice-enabled systems where it can work as probably something like GM OnStar. And then we have a very high-end infotainment system. Talking about cloud, how the cloud design should be, right? So we have built it to be a very modular architecture within the cloud. So a lot of microservices that you need to build in the cloud, unlike as opposed to a very monolithic architecture. And this helps us to scale our cloud, so that it can handle millions of devices data that is ingested in the cloud. So different sorts of applications, of course. And talking about the data that is, that needs to flow from the devices. So there is, as you can see, lots and lots of data about driving behavior, diagnostic data, firmware upgrades, exception alerts that needs to go. And while we are talking, about the future, 4G technologies and autonomous, talking about the present, we are, of course, dealing with lots of challenges, one of them being a low bandwidth. So while we are talking about 4G and 5G coming in, what we are already supplying to OEMs is actually on 2G, right? So how do I make all these data go to the cloud in a meaningful way on a 2G network? So that's a big challenge. And of course, cost is also very important here, right? So we have seen presentations talking about putting in hundreds of sensors in the car, in the telematics unit, but we know, right, even putting one sensor on the device costs, increases the BOM. And that's a challenge for both, us as a tier one supplier and also to the OEMs, right, where, they are very cost sensitive. So, how the telematics is enabled is basically you need to have a modem, of course, a microcontroller which can do the processing. And moving a 2G modem to a 4G modem adds a huge cost increment, right? And that's a challenge, as I said. And talking about if you are place, let's say, camera, that's again a big challenge, not only in terms of computing power, but also in terms of the bandwidth that needs to go for it to connect to the cloud if you are want to have a live streaming from your, from your vehicle. So yeah, just summarizing that, while we are talking about future, we are also, kind of grappling with the current, challenges that we have. But of course, we are getting ready for the future. This is a future cockpit that we showcased in CES, where we are building an empathic cockpit where once you get into the car, the environment changes rapidly, and there you have to do lots of processing on board. Lots of processing needs to happen on board, so that means a lot of computation. But of course, as I said, this comes at a cost, basically. So yeah, once basically the data is onto the cloud, what happens next is something I'll let Saurabh cover in the next few slides.
Thanks, Amit. I represent a sister company of Amit's called Motherson Infotech and Design Limited. This is a company focused on enabling companies on the Industry 4.0 journey and also around whatever is needed for manufacturing from an IT perspective. So to start with, I have a small quiz as we are kind of going towards the end to wake up everyone. So how many vehicles are there on the road worldwide? As I speak the options, please raise your hands so that we can get to know what the audience feels. You are free to use Google on your phone. So A, 100 million. Anyone? B, 600 million. C, 2 billion. So we see a few hands here. And D, 1 billion. So great, I think so the answer is 1 billion and everyone is right. So almost 1 in every 7 people, there are vehicles there on the road. And in India's perspective, it's almost like 1:9 or 10. But the key question is, what percentage of these vehicles on the road are any kind connected? And which is the theme of the topic today, of the conference as well. So A, 50%, how many? Fail, none of them, great. B, 10%, okay. C, 1%, okay. And D, less than 0.5%. So great. So I see a lot of hands for D, 0.5% and less, and it was very difficult for me to figure out what's the real number. It was coming out when we were checking out, it was in the range of 0.2 to 0.3%, which is very alarming. We say if there are 1 billion vehicles, there is less than 50 million vehicles which are connected. While if we see number of people connected on the net is almost 50% of the population, almost 3 billion, 3.5 billion people, which is a kind of worrisome figure. We are talking about the possibilities, but there is a huge amount of vehicles which are not connected, and this talk has been happening for almost 7-8 years now. So there is a huge thing on the ecosystem which we need to work on. There is definitely the telematics, the telecom infrastructure is ready. The key thing which is happening is the auto ecosystem needs to put the telematics devices in every vehicles out there. Today, that comes only in the premium segments or the top variants, or you have to shell out at least $100 to get in. So getting the sensors out is one of the biggest challenge, and once that is there, we can unlock a lot of use cases. While a lot of people talked about autonomous driving and all, there are very fundamental use cases, if worked properly, can build the trust in that data as well. Most of the use cases we have seen today have been talked about in the area of safety, which is the most prime. The second is in time of saving time and cost. And third, improving the environment. While there are futuristic use cases which are yet to be matured with the level 2, level 3, level 4, and level 5 autonomous driving methods, a lot of use cases are around logistics, battery range prediction, security and monitoring, predictive maintenance, driver performance, usage-based insurance are today practical with the kind of technology and applications available. With just the usage ticking up, we see this going up. I'll talk about 2-3 such use cases where we are working at Motherson Group, and that will give you an idea from a practitioner's perspective how things are maturing. The first key use case is driver performance. How can telematics data help understand how the driver is behaving? So this is an example of the app, the device which Amit's team has made called Roller. it might not be much visible, that talks about my house to office journey with a driving score of 3.2, which is really bad, and my overall average score is about 6.6. But if I really look at what's happening is some days it's at 10, some days it's pretty low. And that really happens when my wife drives. When my wife drives, she is a very conscious driver. She makes it really smooth driving, but when I drive, it's at 3.2. So the whole idea is we have a measurement framework to know how good a driver is. We are working towards a recommender engine to kind of influence the driving behavior and give real-time feedback as well. So the whole idea is how can we do better at driving? These are fundamental use cases. We are not talking much of moonshots here. We are talking about very practical things which are possible today. These things, if the data are very maturely used, can be used for insurance, can be used for fuel consumption, can be used for better vehicle maintenance as well. The second is my favorite use case. This is about dynamic battery range prediction. So if you look at the map, this is a map driving from this location to Nandi Hills, which is a favorite destination for all Bangaloreans. This is somewhere around 65 kilometers from here and return. So in a typical gasoline vehicle, we have a range of about 400 plus kilometers in a tank full. But in case of an EV, we get anywhere from 100 kilometers to 150 kilometers, provided you have a new car with a very well-running battery. So the biggest thing which we feel is, we have read through the feedback which have been posted across, people think about is the range anxiety. If I go to a place, will I be able to return? Yes, if I go to office and come back and I'm staying in close vicinity, I will be able to come back, but can I take short trips? So range anxiety is a big problem unless worked on properly, and a lot of data which relates to your consumption, which means how many people are traveling, are you switching on the AC, how much are you idling, what's the traffic light. Using a lot of that data, how can you predict whether you will be safely able to come back, or you have to take a detour, you have to go to a shopping mall, recharge your battery, watch a movie and come back home. So this is the second use case which is of our interest. And third is moving towards predictive maintenance from preventive maintenance. Today, most of the car alerts are towards your engine gets heated up. In my 10 years of driving, I have never seen that yellow light buzzing. But yeah, if it buzzes, then we should know what to do. Maintenance overdues are there. With the kind of telematics information which we have, we can know a little bit on the battery degradation when the battery replacement is coming. If we have more sensors out there, we can know when the puncture is going to happen, or whether you're driving on a low flat tire or an overheated engine. With more information available, braking, engine load, when to get your car servicing is also possible. A lot of these use cases are possible if we kind of work diligently on each of the use case properly, but it's not about just putting in sensors, getting the data, and magic will happen. As a data scientist, we kind of work towards properly defining the use case, gathering the data from the IoT, making sure the data quality is done, running the models, training the models for months and months, and then unlocking the value. This is a tiresome journey. While people think only about telematics as getting the data, but the huge value lies in getting the things working. So before we conclude, these are some few thoughts which we learned over working with few of the OEMs. Today, a lot of the OEMs have the data with them sitting in their service centers, sitting in their sales offices, with the machines, with different. But even within the company itself, the data is not being stitched together to get a full picture of the car or the history about it, which kinds of brings a very fundamental problem whether any of the telematics is possible. Where else, when we look at the new age companies who are building the cars, they are kind of building the ground up data-driven approach. The second challenge which we see is there are silos not only within the company, but also in the ecosystem, which is a point which was brought about multiple times today in the conference. There are OEMs, there are the fleet aggregators, there are map providers, there are insurance, there are regulatory authorities, and then there are the third-party car service providers. The combined efforts to share data and collaborate is where the value will unlock. Now, the typical question happens, who owns the data and who will share it? At the end, we have to see the data belongs to the customer and he should own it. Now, how do we unlock the value? Keeping him in the center will be the key thing. Thinking about if you are able to get the data strategy right, then the thing comes in, you hire a data scientist, give him everything, and it will happen like a matrix. Being a Matrix movie buff, it has the first jump effect where you hire the data scientist to give him the data and he does his first jump and he falls. So the thing is, you have to understand that getting the data and the data model and the analyst will not help only. You have to train the model multiple times, and it might look easy. It might look easy in reading up hundreds of articles, whether it's on Fortune, whether it's on ET Automobile, but the whole thing lies in training the model and getting your story right. Like Usain Bolt said in this famous quote. To conclude, just an example from the multiple self-driving cars, the one key metric everyone is looking at is how many hours of training or how many miles of training they have done, which the Google self-driving project is leading, which has completed 10 million miles on the road over the last few years, and almost 5 billion miles in simulations. So training is the key to make you successful, and that's where we will kind of end our presentation and open up to the audience for any questions.
Thank you so much.